Hey everybody in transition math this week. So you guys don't have your midterms to look at, but it's okay. We'll look at them next week and we'll go from there. So we'll just go ahead and get started to lesson 69. Just before I get started, I just want to remind you that we'll have some tutoring hours. So if you want to attend those on Zoom, you're going to be on Friday, okay? So Friday, 4th of February, and it'll be from 12:45 to 2 p.m. Okay, so you can ask your parents where the link is, and they'll get you set up to attend those if you have questions. Okay, because I'm going to try to attempt to answer any questions you guys have over your homework and things of that nature. So just come if you have questions to ask about your homework and everything. That's in 2 days from now, or whenever you watch this video, but Friday, February 4th. Okay. All right. So now let's go on to our lessons here. So we're going to talk about lesson 69, right? We left off lesson 68. So 69, I'm going to write this out. So lesson 69. We're going to talk about fractions. Talked a lot about fractions this year, right? But we've talked about converting fractions to decimals before. And most of the time it'd be something that's relatively simple, right? And so if we had something like in example 1 here, we had 2/5. Okay, we want to change that to a decimal. So most of the time, we just say this will make it pretty simple, right? We want the denominator, oops, messed up the denominator, our denominator of 10, 100, 1,000, something like that, right? So in this example here, it's pretty simple to see that we could make it 10 here. And in order to do that, right, we'd multiply top and bottom by the number 2. So then we'd have 4/10. Right, so we remember our place values after we have our decimal, right? So our decimal is here, and then, right, before the decimal we have our ones place. After that we have our tenths place, right? We can think of it as being like that, and then so on and so forth. We have our hundredths place, and then over here we have our 1,000ths place. So then for this one right here, this box here, you can see that it corresponds to this first place right here, right? So then we simply would just draw or write 0, and we write our decimal, and we write 0.4. Now the only reason why we draw a 0 before a decimal place is to just be clear that we're talking about a decimal here, just in case it looks like just a little dot on the paper, right? So it just makes it look clear. So 0.4 is how you do that one. And then if you had something a little bit more complicated where you had 9/9, and this is not over 10, but if we had 9/20, right, we'd want something that ends in 100, 10, 100, or 1,000 for the denominator. So we can see that we'd want it to be 100, right? So if we want it to be 100, we have to multiply top and bottom by 5. So nothing complicated with multiplying. These, I'll just point out that you don't ever want to cross reduce in this case, right? Because if you cross reduce, then you won't get a denominator. That would be 100. So then 9 times 5 is 45, and then the denominator is 100. So now you can see that this corresponds to your second decimal place up here, right? Or 100 is right there. So then you'd write this as 0.45. Right? Okay, and then the only other one that I'll mention real quick, and I'll put it up here in this top corner because we're in another room on this page here. But if we do 59 over 200, actually it's over 250. Right? You can see that we'd want to multiply this number by 4 on both top and bottom, right? And then if we multiply that by 4, right, do our due diligence and multiply 4 by 59, we get 236 over 1,000. And that corresponds to this last example here, or the last place value that we drew up in this spot right here. So we'd have 0.236 for our decimal number. Okay, so that's our typical way that we were making our number of decimals. So let's go on to our next example here where we're actually, it's a little bit more complicated. So if we were to convert something, here we have, for example, 2, of something like 3/8, right? So this is part A here. So if we were going to write this in another way, right, we could also write, I'm going to use a different color here. If I was going to write what this means right here, you guys probably say it's 3/8, right? Or you can think of it as 3. Let's see if I can write this right. 3, and this is division sign, so 3 divided by 8. Okay, and so then if you remember, right, from division, and that just means that you have 3 and you're dividing by 8. Okay, just like that. Right? So then we can divide this because we could try to make 8 here end in 100, 1,000, or 10, right? It obviously is not going to work for those. So the simplest way, instead of just trying to go to higher numbers, is just to go ahead and divide them. So first we can see that 8 does not go into 3, correct? Right, so we can put a 0 there. And then we can go ahead and put our decimal here. And then we'll go over here past the decimal, and we can see that 8 will go into 30, right? So if we practice our multiples, so I encourage you guys, if you don't know your multiples, you need to be practicing these, right? So 8, 16, 24, and 32 would be the next one. So 24 is the one we go, so that'd be 3, right? See if this 3 will show up a little better here. 3, okay? And then we'd have 24 down here. We could subtract that and we get 6. And then we bring the 0 down. And then 8 would go into 60. 7 times would be 56. So we put a 7 here. And we have 56. So doing it step by step like this, we have 4. And then we can keep adding zeros as long as we want, okay? And then 8 goes in 45 times. Okay, so then when we do that, then we have 40, and then we subtract that. But the 0 is our remainder. Okay, so now might seem a little tedious, but this is one way to make sure you can get the decimal. have a fraction, right? We have 0.375 as our answer there, right? So we can box it in as our answer for that one. Now if we go to B over here, we have 17 over 40. So this one might seem a little bit more daunting, right? But we have to just remember this means what we saw up above, right? It's just there's a divided sign. So then we do 17 and divide it by 40. Make sure you give yourself plenty of room to do this, right? So 40 doesn't go to 17 at all. We know that. Write a 0 here. Keep adding zeros here, put our decimal point right above. And then it goes in 4 times. Okay, so 4 times would be 160 here. And if we subtract, we're going to get 10. Bring another 0 down. It's going to be 2. This will be 80. And we subtract and we'll get 20. Another 0 down here. And then for this last one, we'll have 5. And 5 will go in 200 times. So I ran out of room on my page here. Oh. But we'll do subtract, and we'll subtract 200 here, right? So my remainder is 0. So then my answer here is 0.425. Okay, and then let's look at one more real quick. Okay, so if I did one more real quick here, I have 5 over 6, right? And remember, right, this also means 5 divided by 6. And 5 divided by 6 can be written like this. So 5 does not go, or 6 does not go to 5, right? So then that's 0. You have a point on top. 6 goes into 50, right? You have to practice your multiples again. We have 8, and that'd be 48. Subtract this, we get 2. And then we can bring a 0 down, and that would be 3. And that would be 18. And that would be 2, 0, 3. And you guys can see, see this pattern here, right? So if we keep drawing this out, I keep getting 2 for my remainder, and then I'm going to keep getting 20 here, right? So this 3 just keeps on multiplying itself, right? So then in this case, this one's a little bit more complicated, right? But you can see this 3 keeps showing up. So we'd write this as point, let me say 8, 3, and then we do this curious thing. You don't put it in a separate color. I'm just showing you in a separate color so you guys can see. Put this little bar on top like this. Okay, and this bar on top just means that it's repeating. Okay, we put a little bar above that. So that just means that 3 keeps going like this. Okay, but you just write 0.83 and you just have this bar on top. Okay, so you guys can pause and do your building skills, and then you can come back when you're ready to move to the next lesson. All right, so then we'll go ahead and go to lesson 70 here. So I'll go back to blue here. I can do that. So lesson 70. Okay, so for lesson 70, we're comparing fractions. Okay, so the best thing to compare fractions, so I'm just going to write this as our title. So compare fractions. And there's basically one step here that will help us, right? So if we expand fractions, fraction of t to have the same denominator. That'll help us compare it, right? Because then we can compare apples to apples, if you will, right? So then if we had, in our example here, if we have 3 over 7, and we have 5 over 11. Okay, so they asked which one is bigger. Now you might remember, right, we had these little things like this where we had this one, right, and we had one that's facing this other direction, right? So good way to remember this is that the mouth eats the largest, okay? That's all you really need to remember about this. Okay, so we'll close this thing off, right? So it eats the largest. Now, in order to make our denominators, our denominator to be the same here, we got to think about um, what we could do to make them the same, right? So we're looking for what's called the least common denominator, right? So if we think about 11 first, we can think of 11, 7 doesn't go into 11, right? And just keep on going. So 22, 33, 44, and well, I'll tell you one trick is actually you can just multiply the denominators together if you want to. And so then if you do 7 times 11, right? 7 times 11, then you guys probably know you get 77, right? So now we need to figure out what we're going to multiply each one of these by, right? So if we're going to do this one, you're just multiplying by 11 over 11. And this one you're going to multiply by 7 over 7. Okay, so if you do that, you have 33, and 33 is over 77, and this one over here is 35 over 77. So now it's pretty obvious which one you're going to pick to be the larger one, right? Now you can go ahead and put your mouth facing the fraction on the right. So it wasn't obvious at the beginning, now it's pretty obvious. Okay, so now let's go ahead and move to another example. So if we have 9 over 10, and then we have 13 over 14. So 13 over 14 here. So like I said, we can find the least common denominator for these, but there are the other way is to just go ahead and multiply your denominators. Okay, so the least common denominator here, I'll tell you if you multiply them out, you're going to find that the least common denominator is 70. So let's do that first. So if we're going to find the least common denominator to be 70, then we're going to have to multiply this one by 7 over 7, and then we'll multiply this one by 5 over 5, okay? So then we'll have 63 over 70, and then 13 times 5, we'll have 65 over 70, okay? And now we can see that this one on the right is bigger, again, like you saw before. Now, like I said, you can use that trick where I said you can multiply the denominators by each other, right? So if you did 10 times 14, you get 140. And that's a little bit easier to do, right? So let's pretend we're going to do this over here. So we're going to use this one over here instead. So now if we do that, right? We do 9 over 10 times 14 over 14, and then we did 13 over 14, multiply this one by 10. And if we did 9 times 14, we get 9, 4, 36, so we get 126. Right? I'm just doing this quick math in my head, but you guys can multiply it out too. And then over here, you get 130 over 140. Right, and then you'd still find the same thing over here. You'd find that the one on the right is bigger. But that's just another way you can think of it. You can just think of it as multiplying both of your denominators that you had over there, right? Those are both your denominators. And then let's look at one more real quick. Okay, so one more real quick. This one is actually it's probably the easiest one to see right away with the least common denominators. So we have 11 over 15 and 7 over 10. So if you think about this, 10 doesn't go into 15, right? So you can write all these multiples out if you want to, 10, 20, 30, right? We did this before, and then for 15 you can do the same thing. Okay, so we found 30, right? So 30, so then we were doing this before, we were just, okay, we're just gonna circle this, okay, we found it, right? And then for this one right here, this is the second multiple, and then for this one, this is the third multiple. Okay. So then we'd want to multiply this first fraction by 2 over 2, and then multiply this second one by 3 over 3. So then we have 22 over 30, and then we have 21 over 30. Oops, 30. And so then the one on the left here is slightly larger. And then the last part of this lesson here is comparing fractions by changing them to equivalent decimal numbers. So we just learned about that in the last lesson, right, Demi? So we had a fraction here, and we did, let's just write these here. So this is, for example, 2. So if we want to compare 5 over 6 and 4 over 5, right, we could use our trick that we used before where we find the least common denominator, but if we want to compare, and this is by changing to decimal, then I gotta do a little bit more work, but it's not too bad, right? So I mean, have to do 5 divided by 6. We did that a little bit earlier, right? So if we did 5 divided by 6, it doesn't go in 5, but then it goes in 8 times here. That gives us 48. Subtract, we get 2. Then we can bring our 0 down. We have 0. We have 3. Oh, we forgot to put our decimal point up here, right? So it's 0.83. And then we had 18 again. We have 2. We'll bring the 0 down again. And we just have our 3 repeating, right? So for this first side, we have 0.83. And this top thing here means it's repeating. And then we do 4 divided by 5. And maybe I'll move it a little bit to give myself more space. Okay, so 4 divided by 5. So 4, 5. So we have 0 here. Then 5 goes into 40 8 times, right? So 8 times 5 is 40. So you don't need to do too much math here, right? Because the first time we do it, we're golden, right? We got 0 there, so 0.8. So then we have these to compare. We have 0.83 repeating compared to 0.8, and you can see that the one on the left is bigger. Okay. And then trying to think if there's, I guess we'll go ahead and do one more real quick. Okay, so if we have 7 over 20, and we have 4 over 11, so 7 divided by 20. If you guys want to follow along and pause as you go, you can certainly do that, or pause and then do it, and then come back and see if you got it right. So 0, and then if we do this next one here, we can write a 3. Oops. I think I got a little too far to the top of this. Okay, let's see if this works here. So I'm going to write a 3, and that's 60, and then I can subtract to get 10, bring my 0 down, right, and then I have 5. So I have 0.35. 0.35, and 4 divided by 11. My decimal, I have 0, of course, there. This is 3. This is 33, right? Because 3 times 11 is 33. I have 7 for my number here, bring my 0 down. And then I have 6 here. All right, so at this point, I can stop if I want to, but I can do another one if I want to. But I have 4, and I have another one, and I have 3. Okay. So then I know at least that it's 0.363 without going any further. I can see that this number on the right is bigger. Okay, so we will do this last one real quick. Okay, so we had 10 over 13. So 10 over 13. And then we had 7 over 9. Okay, and like I said, maybe try it yourself. You can pause the video and then just make sure that you got it right if you want to. Okay, so 10. Oh, I'm going to go back here. 10 by 13. Doesn't go into 10, right? So then we have to go all the way over here to the next one here. And 13 is where you're practicing your multiplication tables, right? So if you do 7, you're going to get this answer here. But like I said, you're just going to have to tough it out for a little bit. But if you do 7, then you get 70, and then 21, so you get 7, 3, 21, 91, and 9, 0. And then, 90. And then 13 will go into this 6 times. Okay, so for our other 0 that we brought down, 6. And 6 right here will be 78. Subtract that, we'll get a 2, another 0, and then so on and so forth. So this would be 7, 6, 1 here. Or 7, 6, 9. I don't know what I'm. Okay, let's go back here real quick. This is 12, right? I put this in the wrong spot. So this is 12. I'm gonna put my 0 back here, and then let's draw this another one. So 7, 6, and I put 1 there, but it's 12. And then if we try to put 13 into 120, find out that we get 9 for that answer. And so then we have to do 9 times 13. Okay, so 9 times 13 would be 117. And we have 3 left over, and you keep repeating this and keep going. Okay, but we'll just stop here. So we have 0.769 for now, and then we'll do 7 divided by 9 right here. Okay, and then we have 0 here. We have our decimal, and then if you remember your multiplication tables, right? This will be 7 here. This will be 63. We'll get 7 for the remainder. We'll have another 0 come down, and you can see that we'll just keep getting 7 again. So this will be 63 again. We get 7 again. We have another 0 down here, and then we'll have to keep writing 7, right? So we're going to compare our numbers here. We have 0.7, and it's 7, and we could write repeating on the top there, right? So these numbers are very close. It's hard to tell until you calculate this. So then our number on the right is slightly bigger, right? Okay, so that's it for our lesson 70, and then if you want to come back for lesson 71 and 72, it's on the same video, but you can pause and do your building skills and then come back here. Okay, so lesson 71. So right there here, so lesson 71 for transition math, right? So 71 here, we have complementary fractions. Okay. So we know this fact, we've talked about it before, right? But let's write it down again. So we know that a fraction, whoops, I got for my pen here, it's on our iPad. Okay, a fraction, and my A there, so a fraction is worth the value of 1, okay, so the value of 1 when top and bottom are same, or you could just say the same number, right? That's not too surprising. So then if I said in example 1, write fractions worth 1. Okay, so say example 1 says write fractions worth 1 using, and then I said first one, I said using 5. Okay, so then if I was going to write a fraction worth 1 using the number 5, right, then I could just simply write 5 over 5, right, because 5 over 5 would be 1. And then if I had 9, right, then I can just write 9 over 9. So any number divided by itself is 1. And then similarly, right, they have a couple other examples to look at. So if we had 29, then I'll just write 29 over 29. That'd be 1. Okay. Oops. move this thing out of my way here. Okay. Okay, so then, and the last one they said is 13.5. Okay, 13.5, this looks like a funny little one here because it got the decimal. But you can trust me here, right? So 13, if you did 13.5 and you divided it by 13.5, right? That's just 1 because if you divide any number by itself, it goes into itself once. Okay, so then the next part of this is talking about complementary fractions. So if we're going to do this, we'd say example 2, and we're just going to say tell the complementary fractions. Okay, and then before I start doing this, there's one little fact here, right? Fractions are parts of wholes, right? So if I was to write a little fact here that we kind of already know, but just to reinforce it, and say that two fractions add to 1, right? They add to the number 1 if, right? If the numerator, so the numerators is the top piece, if numerators add to the denominator number, right? So if I have denominator, so this first, so if I can finish one of my examples here, right, where it's tell the complementary fractions, and then I said, well, for 3/8 then. So for 3/8, what is the complementary fraction for that? Well, using my fact here below, 3/8 says two fractions add to 1 if the numerators add to the denominator. Okay, so then I'd say, okay, so then my complementary fraction for this would be 5/8, right? Because if I add 3 and 5 here, then I'm going to have 8/8. Okay, and then if I had 5/11, okay, I'm using red here. Well, let's go back to blue. Then if I was going to tell the complementary parts of this one, then I'd just say that this one is 6/11, right? Because if I add these two together, I get 11/11. And then this other one, right, I have 5/10. And then, so then if I tell the complementary part of that, right, you'd probably guessed it already. I have 5/10. Then for this last one, if I had, this one is where they're trying to trick you here. I said tell the complementary fraction of 6/6 right here, right? Then I could write it, or I just say there's none, but I could write 0/6, right? Because if I add that, if I add 0 to it, and then I just would get 1 already. Okay, and then so then in this example here, so let's go to example. We have sheep and goats. Okay, so in the example, it says John has sheeps and goats, right? So he has sheep and goats. And then it says 3/7 are goats. Okay, and we'll use G for that. So I'll say, okay, we'll use a G. And so then we know that if he has animals, right, then they have to equal 7/7, right? So then if those are his goats right there, then what do his sheep have to equal? Well, if these have to add up, right, then the number of sheep he has would be 4/7, right? So he has more sheep than goats. It doesn't tell us how many he has. It just says fraction of his animals, okay? So that's a simple example there, and they have a couple examples in the building skills for you guys to work out. So this is the last part of lesson 71. You can pause here, do your building skills, and then I'll move on to lesson 72. And you can pause and play whenever you want to. Okay, so for lesson 72, we're converting our decimal numbers to percents. So let me move to blue again. I'm going to move my pen over there. So lesson 72 is our last lesson for the week. So we're changing decimals to percent. 2%. Okay, so I might use this symbol here, but if I was going to write it out in normal words, I'd say percent like this. Okay, so then the only really procedure here is that you move decimal point. Sorry for the writing here. It's decimal point 2 places to the right. Okay, so then if I had something like 0.71, which that looks like kind of like a 1, right? 0.71, then my decimal place is right here, right? So I'm going to make it bigger here. So if it's moving 2 decimal places to the right, then I'll just go ahead and move it over here and say 71%. This makes sense, right? Because if we're talking about percents, let's talk about this for a second. If I have 100%, right, that means, right, you can say this, 100% means, and you say this, means everything is there, right? Right, so you're feeling 100% after you got sick. You know, I don't know, some of you guys got sick for COVID, got sick with COVID or whatever, right? But whenever you get sick, right? So if you're feeling 100%, that means that you're feeling fine. And over here you have this into decimal, right? You'd write 1. So that would be going the opposite way, right? So then a couple more examples here, right? So then if you had 0.15 change to a percent, you're going to move your decimal over, right? And you say 15%. And then you're going to do a number that's already over 1, and you're still going to move it 2 places. So then you have 380%, right? So then you're talking about a lot more than just 100%. Now, if you're talking about, let's talk about this one more example here. If you had just a whole number, right? So just say for a whole number, we just go ahead and say add 2 zeros. Right? This is the same thing as moving the decimal place. over 2, but then in this case, right, so this is, for example, 2, we're just working with whole numbers. And if you had 2 and you want to change to percent, then you just add 2 zeros, or you move the decimal place over by 2, so you have 200%. Or if you had 8, right, then you're going to go ahead and have 800%, or 12, right, then you're just going to have 12, or 1,200% if you like it. And then, like we said before, if you have 1, then you have 100%. Okay, so that pretty much sums up what 72 is about. And I don't think I have anything else to say about the rest of the lessons. Just if you have questions, the tutoring session is on Friday, like I already said. So tell your parents that you'd like to do that. So that was Friday, right? Friday, 12:45 to 2 p.m. All right, and then I'll see you guys next week if I don't see you on Zoom on Friday. Okay, you guys have a good day. Bye.